I can only think of one good reason why a person would lie very still for a very long time inside a giant magnet, and that is if they're having an MRI scan. MRI, or magnetic resonance imaging, is the medical technique used to take pictures of the tissues and organs in the body. It's used to detect and diagnose major diseases such as cancer. And unfortunately, a third of us here in the room are likely to develop cancer and need an MRI at some point in our lifetime. Now, most MRI scans involve contrast agents, which are compounds injected to improve the quality of the image, to make the bright parts brighter and the dark parts darker. There are 8 contrast agents which are approved for use in Canada, based on a metal called gadolinium-3 attached to a binding molecule. But there are growing safety concerns about several of these agents because the gadolinium-3 can quite readily disconnect from the binding molecule, and gadolinium on its own is very toxic, especially to the kidneys. So the goal of my research is to develop a new family of safer and even more effective MRI contrast agents. So safety-wise, we wanted to make sure that the gadolinium in our agents would not float away from that binding molecule. So we chose to form cyclic binding molecules using a process called metal templation, in which first the 2 halves of the binding molecule attach to the metal, and then they click together really firmly around it. And we predicted that this strategy would make our agents very stable and thus very safe. And sure enough, in our recent pilot animal study, the first agent we tested showed no signs of toxicity in rats over the 2-week observation period. So that was safety, but we also wanted our agents to be effective, to be at least as good as the approved agents at making those bright parts of the image brighter and the dark parts darker. Now, the way a contrast agent works is quite complex, but a key fact is that the more water molecules which are attached to the gadolinium of an agent, the more effective it is. So those 8 approved agents I mentioned before each have 1 water attached. But because our binding molecules are these flat circles, 2 waters can attach, 1 above and 1 below. And measurements have shown that our agents are up to 7 times as effective as the best approved agent. Here you can see the kidneys of this little rat are much more well-defined after administration of one of our agents. So using this design strategy, we have successfully developed a family of 8 new MRI contrast agents. And it's our hope that one day they'll be available on the Canadian healthcare market, allowing for safer and earlier detection and diagnosis, so that diseases like cancer will be more survivable for that third of us in the room, as well as for future generations.